What's up, guys? All right. Last lesson for the week. Man, can't seem to shake this thing, but I'm hanging tough, just congested and tired and stuff, so it's all good. All right. So, the end game here of volume by finding volumes of particular regions is called volume by different cross sections. And it's just unfortunate that teachers make this seem like it's something different. It's exactly what we've been doing to some extent. So, looking at a region like that, and we've spun it, right? And we could see that if you took a knife and you sliced this three-dimensional region right there, if you opened it up and looked at it, right, you would see a cross-sectional piece that is a circle. Okay, and so really we've been finding volumes by circles, and then the next lesson we spun this thing, around that region, and if you slice a cross section there, you have a washer. Okay, so this last part is, again, visually, it's a nightmare, but I'm going to give you guys a trick to where you're going to get at least one FRQ point out of the two, regardless of what you do, because you're just going to memorize what to write down. But it's important to also understand what you're doing. So, in your brain, I now want you to think of this section that we just kind of talked about. But then what we're going to do is it might not be circles. It might not be washers. Maybe it's going to be equilateral triangles. And so what does that mean? Well, think of this region now, you guys, as flat. We're not going to spin it. Okay, so this is literally something that's flat. And I'm gonna drop down an equilateral triangle, and I'm going to set it. This point is technically coming straight up at the camera. This is really hard to draw. Okay, but this equilateral triangle is just set down. And if I drew a bunch of those, right, you could see that you could create this three-dimensional piece with a bunch of equilateral triangles coming out off that region at us, which is just, it seems impossible, right? And mathematically, it's actually pretty easy. And it all stems from the fact that volume of anything is going to be the area of the formula for the cross-section area piece. And so really, we just need to find area functions for these different types of shapes. Okay, and then enter the trick. So if you look at this printout that I did, okay, 90% of the time, you guys, the cross-sectional piece is a square or a rectangle, which are the two easiest. But you can see that what I've done, and this is not from the textbook, it's not from a collegiate class, this is just my labeling of S. And I'll explain what S is later. But let's find the area of all these pieces in terms of S. So going back here, area is pi times the radius. Well, this radius is S over 2 squared, which is going to have a pi, that's S squared, over 4. Okay, and we could write that as pi over 4 S squared. So the area of a circle that has a diameter of S is pi over 4 S squared. This guy is exactly half of that. And so if you had semicircles, semi meaning half, you would take half of this answer, and so we'd say, hey, that's pi over 8 S squared. Nothing magical yet. This is geometry, not calc. If you want the area of an isosceles triangle, right, the area of every triangle would be 1/2 its base times its height. Well, the base is S and the height is S, so this is just 1/2 S squared. And then let's go down. Let's do this one last. That's kind of the hardest. Let's go to this guy. It's also an equilateral triangle. I'm sorry, it is an isosceles triangle, but now this S is not on the leg, right? This is a leg. This is obviously the hypotenuse. And so this is clearly a 45, 45, 90. And if you go backwards, you might remember your special triangle. This would be S over root 2. If you don't believe me, do S over root 2 squared plus S over root 2 squared equals S squared, and obviously it would work. Okay. And so what's the area of this guy? Well, it'd be 1/2 the base, which is S over root 2, times the height, which is also S over root 2. So that becomes 1/4 S squared. Again, I'm just finding areas. Area of a square with side S, S squared. And then the hard one here, an equilateral triangle is also an equal angular, right? These are all 60-degree angles. And if you cut that in half, now all of a sudden I've got this 30, 60, 90. And I know you guys might not remember all this. Don't get hung up on the reference triangles. But if the hypotenuse of a 30, 60, 90 is S. The short leg is half of that, and the long leg is that short side times root 3. And so the area of this guy would be 1/2 the base, which is S, times the height, which is root 3 over 2S, for an answer of root 3 over 4S squared. Okay? What are we doing? Totally. I'm about to make your life so easy. You guys look at all these answers. Pi over 4S squared, pi over 8S squared. Every single one of these area formulas has what in it? S squared. Okay? And if volume is the integral of the area function, regardless of what shape the AP exam throws at you, you better know it's going to be the integral of S squared. The only thing that changes, right, is that coefficient. If it's a square, the coefficient is 1. If it's a isosceles triangle with S as the hypotenuse, it would just have a 1/4 in front. If it was a semicircle, it'd be pi over 8. But regardless, even if you're totally lost, you're going to integrate S squared. And then the ultimate question, what the heck is S? Exactly, it's RS. We own it. I'm going to show you how to label it. It's just a line segment on these problems. And you guys know line segments are either top minus bottom or right minus left. Okay, so let's look at what they're going to do. You can see that I kind of go over what I just did, but let's roll down to the example. The region R lies in the first quadrant between the curves y equals x squared. That's y equals x squared. Y equals square root of x. That's y equals square root of x. And then you'll see these words. They have to say it. Okay, you'll know that this is a cross-sectional question because it'll say something about perpendicular to the axis given below. Okay, find the volume of the solid formed. Okay, and if you look, A, B, C, and D, what changes is what it's perpendicular to and what's the shape. So remember, our goal is all we need is S. So what is S? It tells you right here. Draw a line segment perpendicular to the x-axis. There's the x-axis. That's perpendicular to that. Label that guy S. It's a gold mine. You guys know what S is. S is top minus bottom. That's root x minus x squared. Okay? I'm ignoring the shape. I know for sure that the volume of this thing is the integral of S root x minus x squared, quantity squared, dx. You get a point for that. An FRQ point. If you can figure out the coefficient, boom, you just get another point. They often have you write but not evaluate. And so we'd be done if we just put the correct coefficient in there. So what's the coefficient? Well, the coefficient comes off of the shape, right? We did squares. Well, if you have a square with S, the area is just S squared. So the coefficient's 1. You're done. Let's not evaluate it. Let's just write it out. Okay? Now, obviously, let's talk about what's going on. But again, you've got everything you need to get these points, you guys, okay? What's happening? Well, this is a square that's coming out of here. It's really hard to see, almost impossible. Okay? If you draw a bunch of squares coming off of there, this is flat, right? And squares are coming up out of the page at us. And this guy's a little square, right? Because the distance across that section is shorter than there. So you just have a bunch of squares coming out of your paper right up at you. It's almost impossible to draw. Okay. So we're good. So let's do the same region. We got square root of x, y equals x squared. It says, hey, perpendicular to x-axis. Okay, go draw your line segment. Perpendicular to the x-axis is right there. Label it S. Whose S is that? You guys, that's our S. Nobody knows what S is. The AP exam's not going to look at that and be like, ooh, it's S. They don't know. But you're going to identify S as a line segment that is always the length of top minus bottom, which is root x minus x squared. Okay, and that is the distance, right? But it's also one side of a equilateral triangle now that's coming out of here. Okay, and so really the volume is just adding up the area of all those equilateral triangles. Well, in order to find the area of an equilateral triangle, you need to know the side length, which is S. Okay, so maybe you forget equilateral triangle, but you better write root x minus x squared, quantity squared, dx. Point, thank you. If you can remember that the shape of an equilateral triangle is root 3 over 4, if you put that guy in front, you're home free. Okay. All right. Let's do these next two. So we've got the same region, root x squared, perpendicular to y. Okay, now it's this way, right? Y-axis perpendicular. Label that S. What is S? S is a line segment. In calc, guys, if you draw a line segment, it's top minus bottom or right minus left. So it's x squared minus root x, but that's wrong because we're right minus left, so everything's in terms of y's. So come over here. We have y equals x squared, and we have y equals root x, which means x is equal to root y, and x is equal to y squared. And so the right-hand side here, that's the y equals x squared. So it's going to be root y minus y squared. Okay, so the volume for sure is the integral of that. Root y minus y squared squared dy. And semicircles, right? There's a pi in it because it's a circle. There's no pi in this guy because that's triangles. That's a common mistake. Semicircles, right? From the front, we've got that pi over 8. Okay, and so you just put pi over 8 in front. That will be the volume of this guy. And visually, what's happening? There's a bunch of semicircles coming up. And you're adding that up. You're creating this shape, right? That maybe on this guy you can see a little better. It's flat on the bottom with a bunch of semicircle dome things coming out the top of it. All right, last one. They love rectangles. Root x, y equals x squared, perpendicular to y-axis. There we go. Got the same s value, root y minus y squared. So we know the volume is the integral of root y minus y squared, quantity squared, dy. What the heck is the coefficient if you have a rectangle with one side 3 times the length of the other? You guys go back to this page. There's your square, right? What if you have a rectangle with one side 3 times the other side? Well, your area is just s times 3s, or 3s squared. So whenever they tell you it's a rectangle, you just steal the number that's in the problem. If it's 3 times as long, there's a 3 in front. If it's 4 times as long, there's a 4 in front. So you come here, you slap in your 3, and you're off to the races. Okay? All right, so how does this show up? FRQ, number 5. Let's make it up. Yeah, they give you a region. Okay, they say, hey, square root of x, y equals x squared. Find, in part A, find the area of region. Yeah, you're going to add up a bunch of line segments. You're going to add up a bunch of top minus bottoms, right? So your area is going to be the integral of top minus bottom, root x minus x squared, from 0, let's call it to, they equal at 1, right? Because 1 squared is 1 and the square root of 1 is 1. So let's go from 0 to 1, dx, and you're good to go. Part B, it says spin it around the line y equals k, where k is greater than 1. Okay? So they just told you, hey, come up here. You're going to spin it around some line y equals k. And you guys are ready to go. They said spin. You got it. There's your spinny guy. Why do I do the spinny guy? Because the spinny guy tells you start there, go to the region. Start there, go to the region. Right? So you would say the volume is the integral of, this is little r, that's capital R squared, which is k minus x squared. K minus x squared. That's capital R squared minus little r squared. K minus root x. All squared. Dx. This is washers. Washers are circles. So you need a pi in front. And you're going from 0 to 1. This would be right, but do not evaluate. So you'd be done. Okay? And then part C, you guys, is what we just learned. Take that same region and let's say that we go perpendicular to the y-axis and we're going to do semicircles. You would label that S. You would figure out your two things just like we did. And that's the entire FRQ. Area is always top minus bottom or right minus left. Spinny guy, you can't go wrong. It's pi r squared or pi capital R squared, little r squared. When they say the word cross-section perpendicular, you draw it, you label it S. The volume is always whatever S is, quantity squared, and then that guy is based on shape. Okay? All right, you guys. So that is for tomorrow. I haven't posted homework yet for it. I got to find some homework and do that. But in the meantime, I'm going back to the couch. Sorry, guys. Take care.